In this lesson we're going to learn how to use the quotient rule. A quotient is when you've got one function above another. We will derive the formula using the product rule, and then I will give examples of how to use our derived formula. So this is a quotient where we've got one function above another. So the first thing we're going to do is we're going to rewrite that by bringing the g of the x to the top. So we've got f of x multiplied by g of x to the power of minus 1. Now we've got a product. But before we start, let's consider what happens when we differentiate g of x to the minus 1. So it's a bracket, so we're going to multiply by the minus 1. We're going to keep the inside of the bracket the same. We're going to take 1 off the power to make it minus 2, and then we're going to multiply by the inside of the bracket differentiated. So we've got that here. If p equals g of x all to the minus 1, then p differentiated is minus g of x all to the minus 2 multiplied by g dash of x. So now we've done that, that can help us differentiate this product. So y dash is going to equal, so we're going to differentiate the f of x to get f dash of x, and we're going to keep the g of x to the minus 1 the same. Then we're going to keep the f of x the same, and we're going to differentiate the g of x to the minus 1 to get that expression that we've just worked out previously. Now we want to simplify this, so what I'm going to do is the first term, I'm going to multiply the top and the bottom by g of x. So that's going to give me f dash of x, a g of x, and a g of x to the minus 2, which would cancel out to put us back in the same position. And then I've changed that plus minus to minus. Now that I've got g of x to the minus 2 in both terms, they've effectively got a common denominator, and I end up with a formula that y dash equals f dash of x, g of x, minus f of x, g dash of x, over g of x all squared. And that is our standard formula for differentiating a quotient. Okay, so let's do a couple of examples. The first thing I'm going to do is give you a slightly different notation for the formula. So here we say if y equals u over v, and we understand that u is a function of x and v is a function of x, then y dash equals v u dash. That means the denominator multiplied by the numerator differentiated minus uv dash all over v squared. So what I like to do is separately to one side is differentiate the numerator and differentiate the denominator. So if I differentiate the numerator, I get 6x plus 1, and I differentiate the denominator, I get 6x squared. Then all I have to do is fill out the parts of the formula. So I get y dash equals 6x plus 1, because that's the u differentiated, multiplied by v, which is 2x cubed plus 4, minus, because that's what it says in the formula, 6x squared, because that's what we get when we differentiate the denominator, multiplied by 3x squared plus 2, divided by whatever the denominator was before, squared. Now let's get another example. It's got sine. We might remember from a previous video, even though we haven't done trig functions, that when we differentiate sine, we get cos. Anyway, the first thing we do is we differentiate x squared, we get 2x. We differentiate sine x, we get cos x. Now all we've got to do is put those into the formula, and we get 2x multiplied by sine x minus x squared multiplied by cos x, all divided by sine x squared. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Staying in field with Winfield.